So welcome everyone to this second Federated PLM Interest Group webinar. And it's driven by the Helipel 2 project from Sweden. And the task of this project is to validate that we can do federated PLM in a cost-efficient and quality-enabled way. And today, Jadil Kuru will talk about LynxWorks, which is the environment we have been developed within this project to do lifecycle management of federated engineering environments. So Jad, over to you.
Thanks, Eric. My name is Jad from LynxWorks. I'm the CTO, and I have Tord here with me, the CEO. So we're a startup and a kickoff from the research work we've done at KTH. I will present LynxWorks, which is, as you mentioned already, Eric, how you manage your federated environment. Given that you have many applications in such an environment, there might be a sense of, control, or how, which applications do you have? There will be many such things. So you might want an environment that lets you manage that. And these environments last for many years. So that kind of support for handling your environment should sort of take care of that over a lifetime. That's why we have this lifecycle management aspect. So like any product you develop or you have lifecycle management, we start to think of the environment itself as a, sorry, my mobile, as a tool or a product that you need to manage yourself. Short background about myself. As I said, CTO for LynxWorks, but until recently, I've been a researcher at KTH, and I've been working with the OSSC standard since 2012, I think, if I remember, and I've been leading this Eclipse Leo project. And if you recognize that project, this is sort of a spin-off from that work, where we're taking the Leo project one step further, and that's what we're building, LynxDesigner, if you're familiar with Leo design. But I will go into much more details about that. Okay, so this is my agenda for today. I wanted to actually start a little bit backwards. Maybe I thought I'd start with a demo where we show how you can create these traceability links between different applications. And in the scenario we have is more, you have a lot of applications, your product data is distributed across many applications. How can you create these traceability links between them? In this also case, you want to think that some applications have support for making traceability links. And in the Helipel project, we're assuming OSSC is the technology to enable traceability linking, but maybe some applications don't. So how do you deal with this kind of problem? Because OSSC is a good technology, but maybe it's not all over your sort of the set of applications you have in your architecture. So how do you deal with that? Based on this demo, I thought we can, discuss sort of the needs. What is it that it takes to create these traceability links? And after that, I will present sort of the LynxWorks solution, LynxDesigner solution that we believe will help you with those needs. Just for a reference, I'm using this, the Genesis federated architecture. This is sort of the architecture that you, Eric, from Saab are promoting, at least within, I guess, Saab. But this is just, again, one kind of federated architecture. We're not assuming that all architectures will follow that. But in this case, if I understand it correctly, and you can help me out, Eric, you're assuming that every discipline is free to have its own development environment. And that we've in this architecture, that's seen as a black box. So how you create traceability within, let's say, hardware engineering or software engineering is, let's say, best relevant for this case. But across five, yeah?
You're absolutely right. But of course, in the long run, we would like to see the same modularity between the engineering disciplines and within the engineering disciplines.
Yeah.
But so it's modularity on two levels.
Yeah. But the focus, at least in this architecture, is to highlight the need for modularity, at the least across these four vertical functions, or whatever you want to call them, domains. Let's say requirements management. You want to be able to have traceability between systems engineering down to hardware or software, across requirements, configuration, change control, and realization structure. So this is just a reference just to explain what we're thinking of when we say federated architecture, in case you were not listening to Eric's presentation last month. By the way, please interrupt me, and I'd rather that you have, I think I have like half an hour, so I'm happy if you don't wait until the end, just interrupt me and then we can talk about it. It'll be more fun than me just talking to myself. But if I can't see your hands raised, so you'll have to just speak up and interrupt me. Okay.
Just my regular comment.
Yes.
You typically want more than traceability, which is supported by OSC. You want to be able to control configurations.
Yeah.
You also need it for code traceability, and you also want to be able to exchange data, and you also want to be able to do lifecycle analytics and reporting.
Yes.
You need all those capabilities. The traceability alone is a prerequisite, but it's not enough.
Agree with you. I will actually get to that, but I fully agree with you, Aaron.
Yeah.
But now the focus here of this demo is just to create. I mean, the basis is having those traceability links, and then that's not enough. Then based on that, then you can do your analysis, and definitely they have to be configuration aware, etc. But let me just focus here on the creation of the traceability links, or establishing this kind of connection between data across applications. Okay, so this is the use case I'm going to use to explain how we're doing it. We have a simple setup here. It's not, of course, the whole architecture. And the aim is that you want to connect, let's say, 4 functions in your environment. You have your requirements management, and let's say it's done indoors next. In your setup, verification and validation is done in Polarion. You have your test cases, test results, etc. You're doing all your planning in Jira. So things like defects and activities like tasks, what change requests are occurring, that's handled in Jira. And then your system of record when it comes to change notices, that also happen to be in Polarion. So these are your final fun functions, and then they're mapping in your situation, in this particular case, for these different 3 applications. Now, I'll preempt the questions about, okay, why do you have requirements in doors? Why don't you put them also in Polarion, for example, and then you don't have this traceability problem? Sure, but I think in this case, if we want to focus on the case of federation, there are valid scenarios where this might happen. So I'm not promoting here a particular architecture of where you put your requirements. I'm just giving a case on what could have happened for whatever reason. Could be historical reason or anything. So I hope you can sort of relax on this kind of
modeling tools which are not Polarion. I mean, you need federated, that's for sure.
Yeah. With that, and I want to not end up in the discussion of where you put things. I'm just trying to find an example where we have a federation. Again, why is change notices in Polarion? We can discuss that, or let's accept it as a setup for now. In this setup, I think it's worth highlighting sort of variations and this was quite interesting to pick these 3 tools, because Doors has native OCC support, but it's a bit limited when it comes to what kind of traceability links you can connect with it. They're sort of predefined with some support. I might be very wrong here, but from my understanding, it's not like you can configure what kind of links and in the direction of these links you can have in Doors next. If I compare it to Polarion, where they also have OCC support, but there you can define, what kind of work items you can have here, what kind of relationship they can have to items outside, etc. It's pretty much more configurable in that sense. And then Jira, which has no native OCC support at the least. So it's really, if you want to do it with OCC, you would need some plugin or some extension that supports them. So there's a richness that you will have to face in your federated environment. Okay, so, and then the use case is about creating traceability links across these environments. And if I take just a simple case, imagine that you have someone triggered a change request, and that's done in Jira. And based on that change request, you create a new requirement, which is in Doors, and then you're creating test cases to validate this requirement. So this is going to happen in Polarion. So there will be a need somewhere in your process to create a traceability link from your test case down to requirements in Doors. And then you go ahead, and I'm just giving a quick one here, and then the focus is to focus on the traceability aspects. Then you go ahead and design, develop, and test this change you're introducing. And once you complete, you're creating this change notice, which is like a record of what has been done in this change. And that, for whatever reasons in this environment, that's being saved in Polarion. And you create this change notice, and then you want to create a link from that change notice down back to the change request and other items for that change notice. I hope it's simple. It's a pretty simple case, but just to illustrate how it's done. Okay, so I wanted to show a demo of how this could be done. And I also, I like working backwards. I'm going to start by showing you how these links would look like across a federated environment, and then how you go about creating them. And I hope this works. Otherwise, I have a backup of demos here. So this is our environment. This is Jira, where we have our change requests, and I have Doors next, where we have our simple requirements. for an air data computer. And then I have a bunch of test cases here in Polarion and the change notices here. And I've already done this setup for a particular case. So you see for this change request, for this test case, I've already connected it to a verifies. This is you see, this is a link to something that happens indoors. And you see that I just need to hover over it. And then without knowing where the data is, of course, I'm going to see this information coming from doors next. If I click on it, of course, I end up in doors next to view more details about this information. I also have my connection to the change request. So now I'm actually getting a delegated UI of information, seamlessly getting information from Jira into a pop-up here that I don't need. I'm not, as a user, I'm not even aware of where this information is coming from. I'm just like logging in, getting that information, putting it in a knife. This is standard OSSC sort of capabilities that Polarion supports, and IBM also, Doors, I should say, supports it here. And then, as I said, Jira doesn't, but that's what we will get into. This is sort of a plugin that we've introduced to be able to do it. Similarly, if you're looking at the change request, change notice, it's going to be also connected to Jira. And you see it's the same sort of interface that's being reused in multiple places. So these are the two sort of traceability scenarios that I've sort of highlighted here that you want to see. And I mean, these are already existing. If you want to create such a link, what you do is typically, let's say you have a change request, which is this one. You want to introduce a new requirement based on this MAC number precision. This is your description of the change. You will create your requirement here, and then you will have your test case. And then you say, okay, I want to connect it to my requirement. And this is standard Polarion functionality. I want to be able to verify this requirement. Typically, you will connect this to a requirement in Polarion if you're working within the one tool, or you can choose to connect to something external. And you click on that, and then you choose your sort of friend application, Doors Next G, and you say, I want to connect to requirements. And then you get a standard Doors Next delegated UI to select your requirement, and you connect to it. And once you have
just as a clarification,
yes.
we keep saying that some the non-IBM tools, they support OSSC.
Yeah,
they support it because you develop the connectors, right?
No, so OSSC Doors and Polarion, that's what I tried to say in the first one. That's actually native. Doors and Polarion have native OSSC support. So what I've shown you here is only configuring Doors and Polarion to do that. For Jira, you'd need something.
Okay, so Polarion comes with native OSSC support. I
Yeah.
didn't know. I thought that you have to use some connect.
No, but it doesn't have configuration management support. So this actually, I think I should clarify also. What we're talking about now is without configuration management, which I think is a separate topic. Someone will spend maybe an hour or 5 on it. But yeah, Polarion comes with native OSSC support, but not with configuration management awareness. Yeah. And then similarly, if you have your change notice in the same way, you can do it. You want to connect. Here you just see that depending on what you choose, you're going to be able to have, because Polarion is configured that way, you enable or disable the OSSC connection because it's not enabled. So if you happen to choose related to, this becomes enabled because there is a connection to the Jira connector. And then you can open the delegate UI for Jira, and then you can do your search here, whatever the change request you're connecting to, and then you will find it here, and then you make that connection. And then you have the pop-up here that I'm showing. So it's pretty simple and seamless for the user, hopefully, with this kind of OSSC delegated UI to make those connections.
And the links are presented. Each tool presents the ends, so they are.
Yes. So the actual maybe we can go. I'm not sure if how many people are aware of how that works, but the only thing, for example, Polarion needs to save with this connection to Jira is only the actual link, the URL that you can see at the bottom. I can't point with my finger. You will see it at the bottom here when I hover over it, right? That link is the only thing Polarion saves. So all that data Polarion is not aware of and doesn't care about. As opposed to another alternative where you can, I mean, Polarion has, for example, a synchronization plugin where you can synchronize all the data from Jira into Polarion, and then you can do internal linking within Polarion. But that means you need to do all the mapping and, you know, all the transformation of Jira data, all these things into Polarion items. And then you can do that kind of link.
And then when you are in Jira, you have no idea what's your traceability relationships.
Exactly, and then also how you did that transformation is nothing Jira. It's someone that Polarion's admin has done. So you're sort of duplicating this information, doing a lot of guesswork on how that transformation looks like, etc. With this approach, the only thing you need to know about, Polarion needs to configure and know about, is just how do I connect to Jira, and you leave the rest of the information to be delegated from Jira, from the source, and or doors, of course, if you have that connection.
Will Jira be aware that Polarion made a connection to some requirement?
Yeah, well, okay, I can explain how Polarion, that's going to be specific per tool, but in Polarion, when I press the confirm button now, what happens is that Polarion will actually communicate with that link here and tell it, say, look, I made a connection to you, here is the connection to me, and then it's up to you to deal with it. Basically, the request is to update this item to connect back as a backlink to Polarion. But in this
Jad, I think that was an end user. You're explaining my opinion too much. The question is, as an end user, what do you see? Do you see this is what I was asking? Do you see the link ends always in both parties, in at least in your use case? So you can see in Polarion the links to DNG and to Jira. You can see in Jira the links to DNG and Polarion, and you can see in DNG the links to Polarion and Jira.
You could, if you choose to configure it that way, is I guess what. So here in Polarion, you see the connection to Jira. But if you go, practically, if you look at this implementation now, this configuration, if you go to Jira, that case, you don't see the connection back to Polarion. But we could have implemented it so that the user gets to see that, but not in this particular implementation.
Okay, so in this implementation, it's all the links are
one way. No backlink.
One way awareness.
Yeah. Yeah, and this with backlink, it's also the question. I mean, the way Jira can see this information, you could either query some, like Polarion, say, look, who's connecting to me, and then visualize it without having to save that link in Jira. The other alternative would be to say, like in Jira, save the backlink, and then you have the problem of having the link in both.
We prefer not to do backlinking, but you can either do a query or start. Yeah. Adopting the link discovery service that we are now in stages of finalizing the specification.
So the ultimate.
Can I ask? There is no implementation of the backlinking service that is available on the market today that people could use. Is that correct?
What do you mean? Backlinking? You don't need the service. You're simply pushing
link discovery. I think
pushing link discovery. You mean, Andrew?
Yes.
Yeah. But friends, my dear friends, we don't dive into the very advanced things before getting through the basics.
Okay.
So let's keep the basics first.
Thank you, Eric, for keeping an eye on us. Okay, yeah. So there's a lot we can show on this, but this is the kind of the capabilities you want. But again, this is just creating the traceability links. This is the demo. If I share the video, they've already recorded, so I thought in case it failed. So this is actually, like, from this discussion, I mean, I've did use 4, there's probably sure, but that's the most basic need you need is, to help the end user engineer to create those traceability links across these applications. And that's what I showed you. And back to what you said, Eran, the whole purpose of this is to be able to do many things. For example, any kind of impact analysis or something. So that's the ultimate aim, is to do that. I didn't mention configuration management here, but I'm leaving that out from the whole presentation today. Now, you want to do that in a systematic way also. So you want to, like, to be able to do this, I think you need to be able to know where your product, where are my requirements, where are my test cases, etc. So for the engineer to do it and configure your platform to do that. So you want to have some sort of control over where is my product data, in which applications, and how do I consistently access this product data. Maybe we need to have a common understanding of a domain model. What is a requirement? What are its properties, etc. So that any system trying to connect to a requirement can get a consistent description of what a requirement is and where you can find it, right? And again, we're OSSC, or at least I am OSSC oriented. So you want to follow standards like OSSC on how to do that in the system. So this is sort of what I think is what we need to do to make this sort of work at a federated level in a consistent way. Otherwise, it's going to be very much point-to-point ad hoc way of creating these traceability links. And this is sort of what we build LynxDesigner for. We think you need a solution. If you have a federated environment where you have many applications, there might be a sense of I mean, that's why I think centralized systems are maybe preferred, because everything is in one place, you have control over it. But if you have it federated, you want to have a sort of some control or management of your applications. So we built this LynxDesigner. It's an application or a solution that helps you manage a federated environment. And by manage, I mean like modeling it, developing it, maintaining it over time, because your tool chain is going to develop over many years, and you want to sort of have control over it and know what's happening and what changes have been occurring. And there are three aspects that we try to cover in this solution. You want to have an overview and an architecture, pictures like this, for example, instead of using PowerPoint or any sort of generic kind of architecture. Maybe you can have an architecture of a tool chain. A very central aspect is the information model. What are my types here of objects? What are their properties in more detail? I'm going to go through the details of each of these. And then also specifically for an application, what kind of services does it provide and consume, so that you can connect and find the dependency between your applications. And yeah, by lifecycle, I mean like any product, I mean like the whole lifecycle from design to sort of maintenance, monitoring, etc. for your whole tool chain. That's what we support. So I wanted to go through these with these three aspects in detail. I want to start with information modeling, because I think this is the most central part of your tool chain. And you know, the product data, what is the model behind it? This is my representation. I think it's a common representation, a general one about what we mean by information model. You can have these three layers. We can talk about the conceptual models. That's basically what's in the organization, what's in our head when we are in meetings and discussing about things. We talk about test plan, part, function. These are the sort of the business concepts you have. They're pretty abstract. They're not really down. They're not digital in any form, right? But they're very important, and you need to be able to capture those concepts. At the bottom, at the other extreme, you have the data model in the applications. If you look at the schema of your applications in the data, you will have also another layer, a much more detailed layer of information model, and that's within every application. And that's basically if you have a database or a file, that's like the XML schema or the database schema of your application. And in the middle, you have sort of more general information models. And these are sort of, you know, not the conceptual ones and not exactly what's in the tool. You typically find these in, let's say, when you do some sort of process modeling. If you take BPMN, for example, these are your activities, and then you might find here the artifacts that come in or out of your activities in such models. This is another model that we like about process modeling. You have an activity here, and then input to that activity is artifacts of some sort, which is, you know, product data, and comes out also artifacts. Typically, these are very high level. So this is conceptual in our head. This is very detailed within the application. And these are pretty across the application. So these are very relevant for your tool chain. But my understanding is that, and I could be wrong, I would like to discuss and be challenged on this, but this could be quite high level. So they're not sort of exact specification of what data should come in and out of your applications. And you don't want them to be, because your focus here is on the process itself. So you don't want to go into so much to details of that. So that's why in LynxDesigner, we think there's a gap where we try to fill in, which is you're sort of complementing this information model in the middle, but with more exact specification of what data you have, and, you know, so what properties do you expect it to have, etc. Within it. Again, not talking about exactly what's in the tool, but it's about the data coming in or out of the tools. So instead of the activities being the input and output of these artifacts are input and output of activities, here we want to talk about the artifacts that are coming in or out of your applications to other applications. But this is very tightly connected to your processes, of course. So a test plan in Polarion or in QM, in IBM QM, could be very detailed attributes. But for your exchange of information, you maybe have a minimal set of properties here that define your test plan. And that's actually what the OSSC domains are. That's the idea with them, right? How you describe these things to exchange them between applications, according to OSSC. But in LynxDesigner, we think the OSSC are minimal. So you want to be able to define your own domain models, which are more specific or much more richer than just the few ones that are minimal. But OSSC, by design, OSSC domain specifications are minimal. LynxDesigner gives you the opportunity to define these in much richer to suit your needs. So this is one central aspect that we support. Was that a comment, or should I proceed? No. Okay. So with this information model, you also, I mean, a parallel aspect of that is to actually design your architecture of the tool. What applications do I have? And of course, one important aspect of that, okay, based on the information model. So this perspective of the model is consistent with the information model. Okay, what artifacts does this application produce? Change request, defect, and task, they're owned by Jira. Change notice and test case, they're owned by Polarion. So you want to get this sort of overview of the architecture to find the dependencies between your applications. And this could be, of course, much richer kind of description of the architecture of your toolchain. And then you can dig one deeper and you move down to a particular application and say, okay, what are the services that each of these applications are providing? So you're sort of going one step down and you're sort of zooming in and you're designing your, and we're very OSSC focused. So this is like a low code graphical way of representing your application. What services are you providing? I think I can dig deeper and you can see a bit more details. But this is like a graphical representation of your operations you can do on the different artifacts from the information model. And again, it's all these three perspectives are consistent with each other. So if you change your information model, it's going to change the actual data coming out of your services, what properties they have, etc. If you do this all together. And it's a low-code approach in the sense that you can graphically model it. It's got complete information so that you can press the button and then we generate the whole OSSC server application for this particular application. And then you have to, there's some minimal development that you need to do to make it sort of customized for your needs. But you do things graphically. Okay, and the output, I think this is sort of like back to what OSSC provides, and that's what we support also in LynxDesigner, is the output is not an API only for machines, because that's typically what a REST API or you can get from OpenAI, but also you get the delegated UI, the graphical interface, so that the user-oriented interfaces that lets user search and select a resource from one application, so you can create a traceability link to that. So we produce those also, as well as the API, the REST API. Machines and humans is what we try to support. Yeah. Okay, so these are the three aspects we provide. And as I said, we have lifecycle support for that work. And in that perspective, we see two main users or needs for this tool. One is for the information architect working on the information model. And the other one is the application architect, designing a particular application and its services to connect in the whole picture. And they will need different kind of lifecycle support. It's sort of different, lifetime for them. For an information architect, you want to be able to design your information incrementally, do some changes. You want to have control over, who's allowed to change things, when, how do you review the process. We support that whole process of changing your information model throughout the life of the toolchain. And for the application architect, also, picking up the information model, how do I develop my APIs? Again, incrementally, how do I deploy it? How do I monitor it, etc.? How do I maintain it? So now I dig a little bit deeper for the information architect. This is typically an information model you have. You will have many of those domain models. And the way we support this lifecycle management is, we store everything in a Git repository of your choice. And through that, you have access to the we control the access to who has access to them, read, write, etc. How do we version control them? Who's allowed to approve them? We can have a whole review process on how to do that. And that's all done by the tool, LynxDesigner. But the data is actually in a Git repository. And once you have that from these, these are not just nice pictures. From that, we produce the data, the binary code, so that you can implement your applications based on this information, documentation, etc. The information model is just the basic data artifact, right? There's no activities in that. Now, if you're an application architect, you will use this information, you model your application. So if you're doing I think this is for, let's say, quality management. This is your test case, these are the properties. And here you get to design what are the operations I want to be able to do. I want to be able to read, update, and delete a test case. I'll have a selection dialog for the end user, but then also have a query capability, the API. So here, this is a simple model of your API. And as I said, it's sort of a low code. So all you need to do is press a button and generate the code for it. But again, we manage that through a Git repository. This model depends on your domain model. So these are sort of the parallel aspects of you design your information model, which is across the whole enterprise. And then when you build your applications, you're sort of specifying services on these artifacts that you have. Yeah. And then based on that, you press a button, we have this low-code approach, and that produces both the API for the OSSC-based API for the machines, but also for the humans, these delegated UIs. And these are easily configurable. So you can set up the layout, what fonts, if you need icons, etc. They can be adjusted to any needs you have. And that's it. And then, sorry, not only that, once you produce that, generate that code, and then we support also the whole deployment and continuous integration, etc. So from that, when you approve the changes on your interfaces, we deploy it into your application. This is a bad example because, as I said, Polarion comes with native support, so you don't need to deploy an API unless you want to develop your own. Of course, we can support that, but Polarion comes with native support, so this is maybe more relevant for a Jira case. There's a bit of a bug here, I guess.
A question here, Jad. If a tool comes with native support like Polarion and DNG,
yeah.
Do you know how to incorporate it in your information model? Because it might be useful for
exactly, definitely. So you wanna, I mean, this is what I actually did in this case. Like DAWs and Polarion had their support, so you don't need to go dig deeper. Let me just jump into the tool. Where is it? Here. You know, if you look in the tool chain here, I chose to model the 3 applications, but there's no point going in here and designing this application. But I still want to model my architecture and say that I have change notices and test cases coming from Polarion. But what I needed to do is go in and design my Jira application, because that is lacking support. And this is when you need to generate the API. But I still think this is relevant to model here. In the case of Polarion, the way you configure, like change notice is nothing natively that comes from Polarion. So you need to do configurations of Polarion to expose what a change notice is. This is done by going into admin and configuring what properties it has, etc.
But are you actually looking at the resource shapes? You're inquiring the resource shapes of every tool to be able to represent the data model, because you need to look at the resource shapes.
Well, okay, so this is, I'm not sure if I answered your question. This is a specification of, I'm not reading DAWs to say it has requirements. Here I'm just modeling myself. So I'm going in here and modeling, saying, look, DAWs has requirements. And then this requirement is actually in my information model. Where is it here?
Yeah, well, if you build an information model, you want to know what are the properties of the attributes of the requirements, right?
Yes.
Just for the sake of the completion of the information model.
Yes.
It could be other use case where the other tool might be even consuming some of those properties. So the question is, are you discovering through looking at the resource shapes? Are you discovering the
I mean,
the schema of the tools, because the tool need to give you the resource shapes?
Yes. So if a tool, I mean, it could be possible if a tool has a, I hope I understand your question. If a tool has OSC support, let's say DAWs, okay, the answer is we don't, but I can envisage that we can communicate with DAWs to get the specification of what the requirement is, to sort of automatically model it. We don't do that. But
to do a discovery, because you always, it's typical, you may have a tool that already supports OSC, so you can just do a discovery.
Exactly. So that's actually a reasonable situation. What I don't want to do, I think what I think one shouldn't do is, let's say, take Jira. I wouldn't want to go in and read Jira's internal schema of how they represent an issue and make a auto specification of the shapes.
No. But if you have an OSLC tool, you want to leverage it, because in OSLC, the way to discover the resource shapes is a standard.
Yeah, so, actually, and I can take it the other way around. For example,
one counterpoint is that you may sometimes want to stick only to the OSLC standard, the published information, and in some cases, while knowing those benefits, to discard vendor-specific extensions.
That could be a choice.
But please, my dear experts, we have to learn walking before we are running. So let's keep to the walking now.
Thank you again. Yeah. But relevant questions, and I think these are possible, what you're suggesting. Yes. I'm almost done, actually, so I'm happy to talk more. How much? Okay, I thought that would be much faster. So this is what we have. I have a very short demo. Again, I have the demo here with the link, so if you want to take it on your time. But just to give you an idea of how it's done, you basically, if you want to develop, so in this case, we developed the Jira adapter because it wasn't available. So to support the federated architecture with Jira in the game, we needed to develop this API. And this approach works for any REST-based application, not just Jira. So basically the steps is you have to model the product data, and the focus again is on what you want to exchange out or in, but not necessarily what's inside the tools. You can start with the existing OSSC domains, but they normally, I would say in many cases, like minimal by design. So you might want to extend them to expose your own kind of artifacts. Then you model your tool chain. And then for a specific, I mean, this is the 3 applications in our case. And then for a specific application, you will go in and model your operations. Do I need to be able to do a delegated UI? Can I read? Can I delete, etc.? And then you want to, I mean, basically we can generate all the code, but you want to also define, how do I grab the data from? You know, how does the connection to Jira actually looks like, so I can get the data out of the system. And then we generate the data, and then basically, develop that connection, and then you're ready to run. What you can also do is tweak how the delegated UI should look like, which properties you want to show, which one comes before the other one. You can tweak that in to make it look more like Jira if you want, you know, colors, icons, etc. And then you can deploy the integrated. With LynxDesigner, you get a lot of developer pages, so you can actually navigate and test your API before you use it in an integration. I can just give you a feel if we have time. I've shown you, this is basically the information model. A lot of it is managed in different projects, so you can have composition. And basically, you just design your application. This is sort of the standard OSSC ones. You can create your own domains or extend those ones. And just, you know, a drag and drop kind of approach to define. Think of it as a class diagram. But these are actually OSSC shapes. So all the properties you're looking at here are defined according to the OSSC shape. And that's complete enough information so that it works and, you know, gives you RDF data out of these requests when you define them with the properties, etc. Drag and drop things to show you something that's happening. And then the tool chain.
Yeah, just one thing. The important point here is that what we are talking about the information that is shared. So it's about exposing a subset of the attributes which we keep in the source application.
Yes.
And not all of them needs to be shared across the tool boundaries. Exactly. Because through the delegated UIs, I can always navigate to the source.
Exactly.
So it's about exposing things, and we are not restricting anything using the interfaces.
Yeah.
Which I think is extremely important.
Yeah. And the other one is this with, I've been in many, I mean, there were research projects, but there's all this with mega modeling. You know, you have these central models of everything you do, and then you add everything to that to be complete. And that kind of projects never end. So you never actually get to do any integration because we end up modeling all the time. So the approach here is to do things incrementally and keeping those models to a minimum and only expose what you need to for that particular integration you're working on. And then you can always add to it or change it. So you don't have to have a whole complete information model for your all the tools. You can focus on developing one application, provide its services, and model the information for that. But the information model is available for everyone, so you can reuse it even when you're doing other applications. Okay.
One question, please. Can you configure different levels of access? Like, I'm thinking of things like authentication and authorization, right?
Yeah. So basically, I mean, the OSSC approach, which I think is very wise, is that the authentication is always, we use OAuth2, for example. So that's always for the end user. When I go in here and view something here, I hope it fails now. No, it did. So now it's actually me, Jad, making a request to Jira to get that information. So if you log in, if you logged into this page, so you have access to Polarion and click on that one, you would need to log in and use it. And if you don't have access to that information, you will just see a login page or unauthorized. And that's done through OAuth2 to keep it simple in that case. And that's actually what the servers also communicate with, your own OAuth token. So
the point is the responsibility of the domain tool. Once you authenticate, it's the responsibility of the domain tool to decide what it can give you and what it cannot.
Exactly. Yeah.
So it's not the connectors that are produced. It's not their responsibility. They can facilitate the OAuth based authentication, but once you authenticate, then it's the tool decision what it can give you what it can
Yeah,
do.
obviously the tool shouldn't give you what you ask if you're not authorized to it, but
Right.
Well,
It's
I
our
mean,
business.
obvious.
What data you can see is the business of the tool.
Yeah.
yeah, no, it's fully understood. Now, my question is, can this work within the context of like a single sign-on, some identity management, one central?
Yeah, I mean, particularly, are we talking about LynxDesigner or the concept of OSSE in general?
Okay.
Well, sorry, the question back. Do you mean, so, okay, I'll answer one and then see if it answers. So here, when you design your application, we're supporting OAuth 2, which is actually the most modern one, the common one, or you can use even basic authentication. So you can just drag and drop. Let me find the thing here first. I need to zoom in just to get where is my configuration box? I lost my configuration. Oh, here it is. Yeah. Here you see that I've designed with Jira. They had authentication, which is OAuth 2 based. So what I had to do was just drag and drop the OAuth 2 and give. Oh, you shouldn't see my secrets, but I hope you're not recording. But anyway, so you're configuring OAuth 2, and then we take care of the rest. So you just have to drag and drop that. We could have.
But
Jira
John, the question.
Yeah.
I'm always confused about this OAuth business. Let's say you do support OAuth 2. Does it mean that?
Yeah.
We don't assume there is a common identity manager, right? So does it mean that the first time you will approach Jira, you will have to authenticate, and then from now on you will not have to authenticate anymore, as long as the other tool maintains the token?
As long as the token is valid, but with OAuth 2, that token is only valid for an hour, and then it has to be refreshed or something. So that's,
okay.
But
it will require, because we don't. I mean, the sunny day scenario is we also use a common identity manager, and then you never even have to authenticate,
exactly.
right?
Exactly.
But if you don't have an identity manager,
yeah,
then you need to authenticate once.
Yeah.
And then with OAuth 2, you will be able to, from now on, at least for 1 hour, you will no longer be requested to authenticate.
Yeah, and if you have single sign-on, then you're not even going to be like you're suggesting. Then it's going to be taken care of by the infrastructure itself. So it's not even OSSE or LynxDesigner. They will take care of that. This is just standard web technologies, so they will just work. What you're seeing here is just an iframe. So if the browser manages this, you're going to be fine from your application. But this is, I mean, it's a messy topic with authentication. So we can also leave that, dig deep. But I hope I answered roughly your question.
Yes, you did. Thank you.
But I think it's an interesting topic, because I always get the question about this with OSSE traceability. Oh, how about security? Because we're doing the link, but it's actually a better security, because we never moving. I mean, when you synchronize data, you lost complete access control. Everyone. I mean, when you copy all of Jira's data into Polarion, it's actually Polarion's account, the user accounts in Polarion that decide whether you have access to Jira data or not. So you have no control anymore about who has access to the data. This is much safer because you're only saving a link and not the data itself.
Absolutely.
Yeah. Yeah, that's quickly. Okay, one more thing. And then also, I mean, the only thing you need to really, like, you model graphically. Did I have one? The only thing you're expected to write to actually make that connection to Jira is, like, given that I have an issue. An issue is actually the Jira topic, the Jira object, and this is Java based. How do I get a change request? So we just ask you to do a transformation from a source element, the actual tissue, to a change request. And this will be, if you jump here, that's based on your information model. We generate the actual data that reflects your information model. And you cannot do wrong, because you can only provide these properties that are available in this object by design. So that was very quickly what you needed to do.
So Jad, how much time did you invest for the Jira interface that you demonstrated now?
I'm a bit biased because I built the actual LynxDesigner, so maybe I'm not a fair representative. But I mean, we hope, for example, you've been working with ShareSpace, and
if I quickly answer, we did a few iterations, so there was some time over it. But once you've done one object, it didn't take long at all. It was matters of hours rather than days. And if any updates I do now, it's definitely sort of under an hour if I want to put a new object in. But it's not it's definitely not onerous.
Yeah. And it's including your learning curve. I mean, you had to learn.
Oh yeah, so I've been through the learning curve, and I found there's some really good tricks like reducing your schemas to only what's needed. So we use the schema definitions to define what for our APIs. We use our schema definitions, and reducing the amount of data in the schema definition was made the Java code much easier, because there's only the properties you actually need. But there are things like that were quicker. But
I mean, if I guess, I would say, I mean, you would need, if you're starting with this, you would need if you give me a day with you, then you can get a first version of your adapter in place. And then any increment is just, like you said, the matter of, because we can also connect it to CI/CD, right? So when you make a change, you commit it to Git, and then that gets deployed.
And you and I did our first implementation with Aerospace in an afternoon. So
exactly. Yeah. So that's roughly. But once for me, it takes 2 hours, for example. But that's, again, I'm not a good
I think we actually have it on a live recording as well, that you did the Jira implementation in 17 minutes. So,
yeah.
Let's not go into the fine details.
Yes. I aimed for 15, but I failed. It took 15.
Hours rather than days was the answer.
Yeah, fair enough. Yeah.
And then, of course, your Jira user interface maybe could do with a bit of a brush up, right?
Fine tuning, exactly. So this is where that's the thing. You can spend as much as you choose to optimize your delegate UIs and configurations and stuff. Exactly. That's true.
But from an end user perspective, what I find very encouraging is that if we decide our integration points, we are in a position to do the integrations at a very low cost and a very low investment. And what we've also seen is that if we follow the standard for one tool, it's reasonably easy to integrate with another tool, which also has an OSLC interface. So for me, that is extremely encouraging. And that is also why I strongly believe in the possibility of building federated environments based on this technology.
And I think it's also to do with this fact that you can't rely on all of them having OSLC. That's why we added this Jira here. Like, you might have in-house tools that don't have it, so you need support to bring them along in your federated architecture. You, or in general, I'm talking here, not Eric, but yeah.
But also, if I have a reluctant supplier, I have the capability to do this myself. Exactly. Again, at a very low cost. And also knowing from the supplier's perspective, knowing that if they don't do it, I can do it anyway. It's also very encouraging.
Yeah. So I think, I hope you got a overview of what LynxDesigner does. It's, these three aspects that we try to keep parallel, but they're definitely connected: your information model, the architecture, and the design of the applications when they don't exist, like we just said. And this is going to be, so we have this lifecycle support because it's going to change all the time. That's it I had. That was it, and I thought we have 10 minutes more questions, or we can bring up this.
I just want, in my opinion, you really want to think about the business of bidirectional navigation, because it's very important. I mean, this is one of the advantages also of the federated application versus some centralized applications. That centralized applications, the domain tools, they don't see anything, right? So so that's one of the nice thing about also the OSC architecture, that all the tools supposed to be aware of all the relationships. I mean, the data, the data owned, the artifacts inside each application supposed to be aware of all their traceability relationship. Bidirectionally.
Yeah.
Because
Exactly.
if it's not bidirectional, you're taking away some significant power. Right?
Yeah. Which is I'm not showing here, but I agree with you, Aaron. Right. So here you want to be able to see from here where you connect, who connected to you, back to where you came from, so you can actually navigate in all directions. Agree.
Yeah.
So it also has to be actionable, right? Be able to, let's say, change life cycles, states from one application to another one.
Not sure what that meant. Actionable.
In a sense, let's say I do something in testing application, and the test is passing, and then I promote the life cycle of the, you know, I tell the requirement, yes, done, tested. Things like that.
So there is something in OSHC that right now we are working on standardizing, which is called link validity. It's not yet here, and that relates to that, because if you promoted it and then someone is modifying the requirement, for example, you want to know that you may have an issue. That we call it suspect links, link validity.
Yeah.
How
do you know about that? Yeah.
This is something we are working on now to standardize. It exists in the IBM tool suite. But again, for that you need a central service to track it, but this is very useful. Once you have link validity, you can track inconsistencies. You can track that something was modified, and then there might be possible inconsistency.
So we touched on two topics actually, which are actively what OSHC is working with now. That's link validity, what you just said now,
and link discovery,
and then backlinking. In this 1 hour.
Link discovery. Yeah.
Link discovery. Yeah. What did I say? Yeah.
But I also think this is very important, that we can see great capabilities within OSHC, but there is also work remaining to be done, and this is one of the reasons why we have started this this webinar series, because there's still enhancement that has to be done, and we also need to raise the awareness of OSHC. So we plan on a continuation project of the HELPL 2 project, which will most likely be international, not only Swedish. So please consider joining us in improving OSHC, and also improving the prospects for creating truly federated environments.
We're going to stop the recording now, and then we can continue.
Thank you, Eric.